Welcome back to the Deep Dive. If you're here, you're looking for that strategic guide, the one that pulls the essential actionable insights right out of some pretty dense cloud architecture documents.
That's the plan.
Today, we are on a critical mission, mastering the foundations of Google Cloud governance.
Yeah, our sources today are all about giving you a clear map of that whole infrastructure landscape. We're covering the core modules.
Everything, right. IAM, the storage and database services.
Exactly. Identity and access management, the huge array of storage and database options, and then the really crucial mechanics of resource management quotas, billing, and of course the whole observability suite.
And the goal here isn't just to list a bunch of features. Our mission is to pull out the practical knowledge you actually need to govern your infrastructure securely, efficiently.
And with some foresight, we want to show you the strategic trade-offs. You know, what to use, when to connect it, and maybe most importantly, how to lock it all down.
Okay, so let's get into it. We have to start with the rules and engagement.
Yeah.
Security first.
Always. That means we have to tackle IAM.
All right, section 1. Identity and access management. At its core, IAM is really just answering 3 fundamental questions for any cloud operation, isn't it?
It is. It just boils down to who.
And that could be a person, a group, an application.
Right. Then what can they do? A specific action or privilege?
And finally, on which resource? That specific Google Cloud service.
Exactly. And when we talk about granularity, it's not just, you can access Compute Engine. It's so much deeper than that.
Okay, give me an example.
Take the compute viewer role. If you assign that, the user gets read-only access. They can list and get Compute Engine resources. They can see the instance metadata.
Okay, so they can see what's there.
They can see what's there, but, and this is the key, that role explicitly stops them from reading the actual data stored on the hard drives of those VMs. That distinction is everything when it comes to the principle of least privilege.
And all of that control really starts from the top with the resource hierarchy, that whole structure organization, then folders, projects, and finally the individual resources. That's not just for organizing things, is it?
No, it's the master blueprint for your security. And this is where inheritance comes in.
Ah, yes. So roles you grant at the top, say at the organization level.
They're inherited by everything below them. And this leads to a critical rule you just cannot forget. A policy you set at a lower level, like a project, it cannot restrict access that was already granted at a higher level.
Let me sure I've got this. So if I get the full editor role at a folder level, and then some well-meaning admin in a project under that folder tries to limit me to just a viewer role,
It does more.
the viewer role is just ignored. I keep my editor privileges.
Precisely. The project admin can only add permissions. They can never subtract permissions that were inherited from above. This is why getting it right at the organ folder level is so critical. You're setting hard security boundaries for everything downstream.
Okay, and when we're defining the who, we have 5 types of identities. You have Google accounts, service accounts. But the sources point to one immediate best practice,
Grant roles to Google Groups.
not to individuals.
Never to individuals if you can help it. It's just a huge operational win. You completely decouple permission management from personnel management. Your workspace admin just adds or removes people from a group.
And the cloud admin only has to manage permissions for that one stable group identity.
Right. It makes auditing your policies so much simpler.
Okay, let's pivot to the application identities. Service accounts or SAs. These are what, for service-to-service interaction?
Yeah, like when a Compute Engine instance needs to talk to a cloud storage bucket, it uses an SA, not a person's credentials.
And we need to be really careful with the built-in ones.
Very careful. You have your custom user-created SAs, which are fine, but then you have the built-in service accounts, like the Compute Engine default.
And that one gets the editor role on the project automatically.
A hugely permissive role. The Google API's service account, which runs internal Google processes, also gets editor by default.
That sounds like a massive security risk waiting to happen if you compromise a standard VM that was spun up without a custom SA.
The attacker instantly has broad write access across your entire project.
That's terrifying.
It's a high severity risk. You have to take immediate action, revoke or replace that default editor role on those built-in SAs with a custom role that actually follows the principle of least privilege. Never, ever let that default stand in production.
Speaking of security, SEs use keys. Google managed and user managed. What's the risk difference here?
Oh, it's night and day. It's about control and who carries the security burden. With Google managed keys, the private key is held securely by Google.
In escrow, right?
In escrow, it's automatically rotated, never exposed to you. The public key is valid for maybe 2 weeks max. This is always the way to go for machine identities.
And user-managed keys are the last resort.
Absolutely the last resort. With those, you are responsible for literally everything, creating them, securing them, storing them, rotating them, recovering them if they're lost.
Wow.
If those keys leak, it's entirely on you. You can have up to 10 per SA, but the security overhead is just massive. It really increases your attack surface. Only use them if you have some legacy system or an integration that absolutely demands a static key.
So to govern all this, we lock down the hierarchy, use Google Groups, and we aggressively replace those default editor roles. How do we manage that at scale without an army of people?
You use the IAM recommender. It's a governance tool that uses ML to look at actual usage patterns. It will actively suggest removing or replacing roles that have way too many permissions.
So if a user has an admin role but has only ever read data,
The recommender will tell you exactly how to tighten that permission set. It forces you to adhere to least privilege across the board.
that's how you make security operational instead of just theoretical. Okay, we know who can do what. Now, where do we put the data? Section 2, storage and database services.
Right, and this is where that core data decision matrix comes in. Is your data structured or unstructured? And what's your workload?
Let's start with the unstructured. Images, documents, backups. The go-to is cloud storage.
Yeah, and it has incredible durability, 11 nines. You are not going to lose your data. But the big decision here isn't just about durability, it's the trade-off.
The trade-off between cost and how often you access the data.
Exactly.
We have 4 storage classes for this. Standard is for hot data, right? High access, no minimum time.
Correct. But as you cool the data, the cost drops, but penalties for early access kick in. Nearline is for stuff you access maybe once a month. It has a 30-day minimum duration.
And then cold line is even less frequent, maybe once a quarter, 90-day minimum.
Yep. And the cheapest is Archive for long-term disaster recovery. That has a 365-day minimum. And if you pull cold line data out early, you pay an early deletion fee.
So that's the strategic choice. You're betting the cost savings against the risk of needing the data early and paying that fee.
You got it. The good news is that even archive data, unlike old-school tape storage, is still available in milliseconds. But the real game changer here is automated management.
You mean object lifecycle management?
That's one way. You can set rules to automatically downgrade storage classes or delete old versions. But the really slick solution for unpredictable access is AutoClass.
AutoClass. That sounds interesting.
It's fantastic because you don't have to guess anymore. It just automatically moves your objects between classes based on how they're actually being used. And the huge benefit is that Google waives the early deletion and retrieval charges when you use it.
So it removes the entire financial risk of getting your access frequency wrong.
The entire risk. It's a great feature.
Okay, before we leave unstructured, what about file system access? If I'm migrating an app that expects a classic NAS.
Then you need FileStore. It's a fully managed, network-attached storage service, supports NFS v3. It's often required for lift and shift migrations, media rendering pipelines, that kind of thing, where you absolutely need a traditional file system interface.
Got it. Now, structured data, relational. The classic choice is Cloud SQL.
Yep. Cloud SQL handles the operational, heavy-lifting automatic patches, updates, backups, high availability failover. It's fully managed MySQL, PostgreSQL, or MS SQL Server. It's great for standard relational needs.
What's the catch?
The limitation is that it doesn't scale globally. It's bound by regional and zonal constraints.
Okay, so if I do need global scale and strong transactional consistency, I have to jump up to Spanner.
That's the leap. Spanner gives you strong external transactional consistency across machines, across regions, even across continents. It blends the structure of relational schema, SQL, with the horizontal scale of non-relational. We're talking petabytes.
So mission-critical systems,
Wow.
financial ledgers, global inventory.
Anything that needs an absolute global single source of truth for its transactions.
Now here's where it gets really interesting for me, AlloyDB. It's PostgreSQL compatible, but it's designed for these next-gen workloads. We see this term HTAP everywhere.
Hybrid transactional and analytical processing.
What is that, and why should I care?
You care because it lets you run both high-speed transactional queries and complex analytical queries on the same database at the same time.
Without needing a separate data warehouse.
Exactly. You avoid all that latency and complexity. AlloDB was built for this. It's up to 4 times faster than standard PostgreSQL for transactions and a wild 100 times faster for analytical queries. It simplifies your architecture and boosts performance, all with a 99.99% SLA.
That's a huge deal for anyone who needs real-time analysis. Okay, finally, let's hit the non-relational, the NoTeXL world.
For document databases, you've got Firestore. It's scalable, has strong consistency with ACID transactions, and multi-region replication. It's just fantastic for modern mobile and web apps.
Yet if I need massive throughput, like for IoT data streams or time series.
That is Bigtable's Music. It's a wide-column database optimized for extremely low latency reads and writes at very high throughput. You should be thinking at least a terabyte of data. It scales linearly. Perfect for ad tech, IoT, ML features.
And the caching layer, the speed demon.
That has to be a memory store. Fully managed Redis or memcached. This is all about delivering sub-millisecond latency for your application's cache. It automates failover, patching. It just keeps your app from bottlenecking on frequently accessed data.
Wow. Okay. Choosing the right data store is half the battle. The other half is governing it all. Section 3. Governance, quotas, and observability. Let's start with those limits. Quotas.
Quotas are just limits on resource consumption. Number of VMs, API rate limits, things like that. They serve 3 really important functions.
They protect you from yourself, basically.
Right. They prevent accidental resource creation, stop runaway billing spikes, and they force you to periodically review your sizing so you're not just over-provisioning out of habit.
But there's a really important catch here. A quota is not a guarantee.
Not at all. A quota is the maximum you're allowed to use, assuming Google has the capacity. It does not guarantee that the resource, say, a specific GPU or local SSDs, will actually be available in that zone at that moment.
To manage the cost side of things, we use labels, simple key-value pairs. Why are these so critical?
Because labels are the only way to get real granularity in your billing below the project level. You can tag resources with team.marketing or environment.prod. Without them, you can't accurately split the bill for resources shared inside one project. It's all about chargebacks and budgeting.
And those budgets can actually talk back to the infrastructure through billing alerts.
Yes, you can set alerts at different thresholds, 50%, 90%, 100% of your budget. But crucially, these alerts can trigger pub/sub notifications.
Which means you can automate actions.
Exactly. You can write a function that listens for that alert and automatically tears down a development environment if it goes over budget. Real cost control.
Okay, flipping to operational health. Cloud observability. For anyone running VMs, the Ops Agent seems like a must-have.
It's non-negotiable. Here's why. The hypervisor, the layer that runs your VM, it can see high-level stuff like CPU and network traffic.
But it can't see inside the machine.
It can't see what's happening inside the operating system. It can't see memory usage, process metrics, application logs. The Ops Agent is installed inside the VM to collect all those internal metrics and make the VM truly observable.
That makes perfect sense. What about checking things from the outside?
For that, you use uptime checks. These are health checks, HTTP, TCP, that test your public services from all over the world. They measure latency and tell you exactly where a failure is happening geographically.
And if the standard metrics aren't enough, like for a game server with a unique capacity metric,
you create custom metrics. Your application can just pass its own data, like the number of users connected to a game session, directly into monitoring. Then you can use that super accurate application-specific data to drive your auto-scaling policies.
Let's talk logs. Cloud logging retains them for 30 days. That's not long enough for most compliance or forensics.
Which is why exporting logs to BigQuery is so valuable. Instead of wrestling with clunky log tools, you can run incredibly fast SQL queries over massive historical log data. It's essential for security investigations or, optimizing network expenses.
And finally, for hunting down performance issues, we have the advanced tools.
Right. Cloud Profiler is amazing. It continuously analyzes your production code to see which functions are eating up CPU or memory. And the key is that it does this with extremely low overhead, so you can get deep insights without slowing down your app.
Okay, so this has been a really comprehensive map. We've mastered identity and structure with IAM, hitting hard on least privilege and the role of service accounts.
And we mapped out that diverse data landscape, contrasting the cost optimization of cloud storage with the high-performance demands of Spanner and, of course, the modern HTAP power of AlloyDB.
It really highlights that managing infrastructure is this dance between securing the identities on one side
and strategically optimizing the cost and performance of the data on the other. Quotas and observability tools are what keep the whole thing in rhythm.
If we contrast the foundational governance for users, like using the recommender for permissions, with the strategic choices for data, like picking a storage class.
It's clear they're both about managing that balance between mitigating risk and controlling your operational costs.
Speaking of risk and governance, we emphasize how IAM policies follow that resource hierarchy. You move a project, and its policies instantly inherit from the new parent.
It's an immediate, powerful impact.
So here's a thought for you to chew on. Considering that immediate security impact of changing the hierarchy, how do you ensure your resource labeling strategy is robust enough to validate that all the associated costs and all the operational metrics are accurately following that resource when it moves?
Hmm. That is the ultimate governance question. It links your security, your billing, and your architecture all together. Thinking about how automation, whether it's those PubSub budget alerts or automated lifecycle management, can enforce all the best practices we discussed today, that's where the real efficiency gains are. Until next time, keep diving deep.